Hello, welcome to my YouTube channel, uh, the Chichi Online Academy. And today we are going to discuss part of trigonometry, where say expressing anything which is in the form of a sine theta plus b cos theta in the form of r sine an angle to be theta plus or minus alpha, or if it's in terms of cos, then you express it as r cos theta plus or minus alpha. Whatever we're going to do applies in both cases. Whatever we're going to do applies in both cases where we are where sine is sitting, it's cos, and vice versa. So without wasting much of our time, just in case you've not yet subscribed to this channel, please don't forget to press that subscribing button so that whenever I drop a new video, you'll be the first one to receive the notification for the video. So I'm going to drop this applies to additional mathematics, A-level for both IGCSE and O-level mathematics, as well as those who are doing first year in mathematics. This is very helpful for this topic or this subtopic on trigonometry. The first example, if A sine theta plus B cos theta is equal to this, or it can be expressed in this form, it means that this R which we have here can be found by multiplying A squared plus B squared. What do we mean? Meaning where the A is seated and where the B is seated, where the number is going to sit here. We can square them, then we add them. The square root of that gives us R. And that means that this angle alpha can be found by dividing the same, the b, the coefficient of cos, divided by the coefficient of sine here. The example reads, express 5 sine x plus 12 cos x in the form r sine x plus alpha, where r is greater than 0, and alpha, which is a number there, it is representing, or it is lying between 0 degrees and 90 degrees. We really have to be very mindful of the fact that in this case, they've used what? X. In this case, we are using what? Theta. So theta and x are representing one and the same thing, and that is an angle for either sine or cosine. So please, that shouldn't actually scare you. So without wasting much of our time, let's get to it. B, hence, find the maximum value of r sine x plus alpha. So let us work out this question. So how do we work it out? Yes, so the first thing we have to do is we write this statement. 5 sine x plus 12 cos x. Now this you have been told that it is equal to r, because since we have to express it in this form, we can equate it to it. X plus alpha. Having done that, then we proceed again. 5 sine x plus 12 cos x. Now this part, the sine, we are going to use double angle rule or compound angle rule. So what are we going to do? What I'm saying is the compound angle is where if we have sine A plus B, this can be written as sine A cos B plus, when we start with cos A sine B. So this is the concept, this is an identity, the compound angle formula. This is an identity which we are going to apply here to work out this problem. So this will be equal to r multiplied by sine x cos alpha plus cos x So having done that, we can rewrite this as 5 sine x plus 12 cos x is equal to r multiplied by sine x cos alpha. We are just using algebra. This is multiplying whatever is coming out of these brackets. Then r cos x sine alpha. So now, equating terms involving sine x and cos x respectively, what do we get? So you can see here from here, what has got x has to be equated now to what has got x this side, meaning, or what we can say, the coefficients of sine x and the coefficient of cos x must be equated. So this has got something to do with sine, and this part has got something to do with cosine. So it will be 5 sine x is equal to r sine x cos alpha. What are we going to get here? When we divide both sides by sine x, what are we going to get? We have is 5 is equal to r cos alpha. This we label it as our equation 1. Then we go to the next one, which has to do with cosine here. Write 12 cos x is equal to r cos x sine alpha. Again, you can see we have got both sides. On both sides, we have got cosine. So we are going to divide by cos x. So after dividing, we are going to get 12 is equal to r sine alpha. We label this as our equation 2. So now, dividing equation 2 by equation 1, what do we get? So, where is equation 2? Equation 2 is here. So we are going to divide the integers around 12 divided by 5. This is equal to r sine alpha divided by r cos alpha. The idea here is to ensure that, remember where we're coming from, we have to make tan alpha. So when you look at this is an identity for tangent function. So meaning, these r's we are going to divide. What are we going to remain with? We are going to remain with 12 over 5 is equal to tan alpha, which is the same as us having tan alpha is equal to 12 divided by 5. So alpha is equal to tan inverse of 12 over 5. What is tan inverse of 12? What is? So using the calculator, we are going to get 67.3801, corrects the 4 decimal places, which gives us alpha is equal to 67.4 degrees to the nearest 1 decimal place. So having done that, we square both equations, that is equation 1 which we have found here and equation 2. So let us square it. 5 is equal to r cos alpha, and also I've got another equation which is 12 is equal to r sine alpha. So squaring these equations, we are going to get this. So we can see from here we have 5 squared is equal to r squared cos squared alpha. And this side we are going to have 4 squared is equal to r squared sine squared alpha. So now we have to add the integers. So what we are going to do is r squared cos squared alpha plus r squared sine squared alpha. This must be equal to 5 squared plus 12 squared. Now we factor out this r squared. We are going to remain with cos squared alpha plus sine squared alpha, which gives us 25 plus 1, 4, 4. This, according to trigonometric identities, this is as good as 1. 1 times r squared, we are going to have r squared is equal to 169. Now, we want to find r and not r squared. Therefore, we introduce something which is going to cancel out or divide with this one. That is half, or the square root of these two numbers. So this gives us r is equal to 13. So having done this, we can see that now we have found all the necessary things which we need. We needed r, we also needed alpha, which we have done. So now we get to now representing it in the manner that which they require us to represent it. And we know that 5 sine x plus 12 cos x is equal to this. So what do? We have found that our r is 13. Sine x plus, what is our alpha? Our alpha is 67.4 degrees. So therefore, we have expressed 5 sine x plus 4 cos x in the form r sine to an angle x plus alpha. So now from here we go to question B, where we have been asked to find the maximum value of this particular function. So the maximum value of r sine x plus alpha is the square root of a squared plus b squared. And this occurs when sine x plus alpha is equal to 1. So now, from here we can see now, we can just get this one. We know that sine x plus alpha have been told is equal to 1. That's where the maximum value is occurring from. So what do? We substitute sine x plus, what is our alpha? Our alpha we are going to get, we won't get the exact 7.4 degrees. We just have to put it, to round it off to 1 decimal place when we are writing the final answer. But in this case, since we are still dealing with calculations, we are going to write 67. That other number which we wrote correct to, or to the nearest 4 decimal places, which is 67.3801. This must be equal to 1. Then what do? So we are going to solve this as a trigonometric equation, which is going to be x plus 67.3801 0.01 is equal to sine inverse of 1, which is going to give us x plus 67.3801 is equal to sine inverse of 1 is 90 degrees. So now working out the value of x is equal to 90, take away 67.3801. So from here, we are going to get x is equal to 26.6199. Rounding it off corrects to one decimal place, we are going to get 26.6 degrees. So the maximum value of this particular function, the maximum value is 13, and it occurs when angle x is equal to 0.6 degrees. You can see that square root here, when we put 5 and 2, we are going to get 169, root of 169 is 13. Otherwise, thank you so much for watching this video. And just in case there is anything, any additions, subtractions, and any clarifications, please you can drop a comment in the comment section. And if there is anything which you would like me to improve on, please feel free to drop a text message, a comment, and I will ensure that I work on your recommendations. Thank you so much. And just in case you haven't subscribed to my YouTube channel, as you can see, we are rolling. Please press that subscribing button. Thank you.